this proves that we should end the semester. Okay, we started talking about geometric design, which means the dimension of the highway. Okay, and can be done in the horizontal alignment, vertical alignment, and cross section. Okay, horizontal alignment means you are looking at the road from the top, the plan view. Okay, so you see the direction of the road and the changes in direction with the curves. And then we have we discuss some points which you have to consider for the horizontal alignment. Then we have the vertical alignment, which is looking at the road from the profile, the side. You see the length of the road and the gradients. And again, whenever you have the change gradient, you have to provide the curve. Okay. And then we have the points which you need to keep in mind for designing the vertical curves. Okay. The most important one is the side distance, and then we have the drainage, and then we have the comfort of the driver. And vertical alignment generally follows the horizontal alignment. Fix the horizontal alignment, then come to this part. Okay, so in the cross section of the road, you are cutting the road from the front. Okay, you are looking at it from the front. Okay, so you see the features like lanes, medians, shoulders. Okay, some of you have made it for the term project as well. Normally, the cross sections are designed for every station. Okay, the station means how much? 100 feet. Even meters, they take 100 meters. In Bahrain, they take 100 meters. Okay, so you normally design and provide the cross section every 100 feet or 100 meters. But if there is a change, after 50 meters, there will be a curve. So it will change the cross section of the road. Okay, so now you will not wait for the 100 meters because you will miss the change. Okay, so the point of change should be covered in any case, whatever the distance is, 100, 10, 1, whatever. Okay. When you are showing the stations, the important point is we already mentioned the station. Okay, if you are showing the cross section, the station is very important. And how to show the station? You can see the notation over here. X plus YY. So the X is the number of stations you have, and YY is the remaining distance. Okay. So okay. So this means how much?
12 stations and 52 feet.
Okay. Like total how much distance?
1200 feet plus 25 feet.
25, 50. Okay, 1250. Okay. And if it was 1252.5, 0.5 will go where? Here or here?
No, 2.5.
Okay, after the plus sign. Okay, so before the plus sign, only hundreds. Then whatever is remaining is after the plus sign. Okay, now we will talk about horizontal curves. Okay, their design. In the design of horizontal curves, the shape is very important. The shape is circular. All horizontal curves have circular shape. Okay, now you can play around with the same shape and vary it to have other types of horizontal curves. For example, we have one which is called as compound curve. Okay, so in compound it's a circular curve. Okay, but more than one circular curves are joined together. So the shape is still circular. Shape is still circular. Okay, and then we have a special case where you have high speed and sharp curve. High speed and sharp curve. In those cases, we provide a circular curve. Okay, either one circular curve or compound curve. But before and after the circular curve, we provide a special type of curve which is called as spiral transition. Okay, spiral transition. So this is only provided at the start and end, where you have high speed and sharp curve. Otherwise, this one is not provided. Clear? Okay. Now, what is special about this curve? The radius. Okay. Circular curve radius is changing or constant. Radius of a circular curve. Is it constant or changing? Constant, right? Okay. For a spiral curve, the radius is changing. Okay. Clear? And how does it change? For a spiral curve, it starts with infinity. Infinity means a straight line. Infinity means a straight line. Okay. And at the end, so it will start from infinity, decrease, decrease, decrease. Every point it will decrease until it reaches the circular curve. Okay. When it will reach the circular curve, its radius will become equal to that of the circular curve. Got it? Clear? So this is a special case, and as I mentioned, only for high speed roads with sharp curves. Now, how do I measure the sharpness of the curve? Okay, what they call as severity of the curve. How do I measure it? It is measured either in terms of radius or degree of the curve. Okay, so on the basis of radius or degree of the curve, you can say a curve is sharp or smooth. Clear? Now, radius you know, right? Distance between. Radius is the distance between
Center of the circle is circumference.
center to circumference. Okay, and the degree of the curve means what? Degree of the curve. Anybody? Degree of the curve means what?
The degree between the angle between
The angle
two radii from the
From-
beginning of the curve to the end of the curve.
from the beginning to the end. From the beginning to the end.
Yes.
Yes. Okay. No.
The section. The degree for the section.
Yes. Yes. Okay. Section. Station.
Station.
Station. Okay. Degree of the curve for a station. And station is how many?
100 feet.
So degree of the curve for 100 feet curve. Okay. Now what is the relationship of degree and radius? We are using the similar ratio approach. Similar ratio. This is total circle and this is circular arc of 100 feet. Total and 100. Okay. Total circumference, total length. 100 feet circumference, angle, degree of the curve. Okay. So you can see here 2, pi, 360, 100, all of them are constants, right? You can merge all of them together. Okay. So you will only be left with two parameters, radius and degree. Okay. So then degree is equal to this much of the radius. Clear? Okay. So what are they to each other? Directly proportional, inversely proportional. Huh? Inversely proportional, right? Okay. So radius increases, degree decreases, right? Now what is good for the drivers? More radius or less radius?
This radius.
Huh?
More radius.
Not formula radius. Yes.
More radius.
More radius is good. That means degree here should be
Less.
less. Clear? Yes. No, you. Nothing. Okay. This diagram and these points tell you some of the components of the circular curve, and you already know them, right? Okay. So what is pi?
Point of intersection.
Point of intersection, right? Intersection between
The tangent. Two tangents. From the beginning of the curve and the end of the curve.
say again.
Two tangents.
Two tangents. Yes. Don't explain, please. Don't explain. Don't explain. Yes. Okay. That's why I started giving the quizzes. It was getting way over my head. When you guys come to explaining, nobody can stop you. Somebody should stop. Okay. So point of intersection between the two tangents. Okay. What is PC?
Point of curve.
Where is it? On the curve. Where is it?
Beginning of the curve.
Beginning of the curve. Okay. And what do we call the end of the curve?
And
End of the curve. Which
point of intersection.
PT, right? Okay. What is delta? What is delta? Yes.
Angle.
Between angle between the dimensions. Okay, angle between the dimensions. Okay, what else do we have? Okay, what do we call the distance between PC and PT? What do we call the distance between PC and PT? Yes. PC is what? Which point? Beginning. PT is end. So distance between them is length of the curve. Okay. Or there is another distance between them. Length of chord. Length of curve or length of chord. Okay. Which brings me to something I forgot in the previous slide. Degree of the curve D has another definition for the design of railway tracks, okay, which says that if you take the angle for one station of chord, that is also called degree of the curve. Okay, so you between the 2 points of the curve, you can have the curve length or the chord length. Okay, whatever you take, the angle between them is called the degree of the curve. Okay, but we use the first definition, which is for the curve length. For highways, we use the first definition. Okay, and both angles will not be same. Somebody is taking chord definition and he is taking this distance, he will have a different angle. And you are taking the curve definition, your 100 feet will have different angle. Got it? But we are sticking to the first one, the chord one. Clear? Okay, so between the 2 points, the PC and PT, I can have the curve length, I can have the chord length. Okay. What else? Okay. Now we have two distances. This one is called E, this one is called M. E means external ordinate, M means middle ordinate. External, middle. Okay. So if you draw the line from the center of the curve, if you draw the line from the center of the curve to the PI, this line will intersect the chord and it will intersect the curve as well, right? From the center, you go to PI, it will intersect the it will intersect the chord and the curve. So the distance between PI and the curve is called external ordinate, E. And the distance between the curve and the chord is called the middle ordinate, M. Okay? So E and M. Okay? Another thing is, if this angle is delta, then the curve angle is also delta. Okay? Now, can delta and D be equal? Delta and degree of the curve, can they be equal? Yes. Yes or no?
No.
No?
Yes, if the only 100 feet.
Yes. Okay. So D can be equal to delta if your curve is 100 feet. But the actual curve can be less than 100 feet, more than 100 feet. Right? Okay. So there is only one case in which D and delta are equal, otherwise they will be different. Clear? Okay. Okay, what else? Yeah. So if this angle is delta, then the angle between this and this is delta by 2. Now this is what? Chord. And this is what? Tangent, right? Okay. And this length is represented with T. Clear? Okay. The equations for all the parameters. Okay. In all the equations, I need two things. What? In all the equations, I need the same two parameters.
Delta and radius.
Delta and radius. Okay. But if you look at the equation of D, if you look at the equation of L, I have D here, right? Okay. Can I replace D with R?
No.
Like I said, don't explaining. Let's say yes or no. Can I do that? Yes or no?
No.
No? What type of no is this?
Yes, for under 100 feet.
Huh?
Less than 100 feet, you can replace D with R. But if it's more than 100 feet,
Very good. You should have dropped the course. Or you should have gone back and done the highway course again. Okay? No. Delta, I can replace delta with R because I have an equation between, sorry, not delta. I can replace D with R because I have an equation between them, right? So I can replace D with the equation of D. It will have R, right? Okay? So that's how. Okay. Let me. Okay, the point of intersection of a curve is given. Okay, the radius is given, deflection angle is given. Okay, they are asking for the parameters of the curve. Okay, and they are asking for the stations of beginning and the end, PC and PT. Okay, let us start with the calculation of the parameters. Okay, so tell me these values: the tangent, the length, the M, and the E, and the LC. Okay, now to calculate L, I need D, right? Okay, D is not D, right? Okay, so D is equal to this much of the R. So how much is this? Then how much is the length? Point. Okay, the remaining. What?
Have a difficult with that question or not?
292.4.
Okay, now PC and PT. Huh? Okay, PC and PT. We have PI given. PI is given, PCI and PT are required. Okay. What do we call the distance between PC and PI? Tangent. Okay. So you just calculated tangent. How much is that? Okay? Now they want PT. How do I calculate PT? Add tangent in.
Can you do plus R? For
Uh,
plus R or
R. Same R or
Length
R
of curve plus
BC
length
plus
of
R.
curve.
plus what?
Length of curve. PC plus length of curve.
Length of curve, right? We can do PC plus length of curve. And you were saying what? Plus what?
Add the tangent.
Add the tangent. Okay? This can be done.
twice?
Okay? Yes. But both of them will not give exactly the same answer. Because we are calculating them from two different equations. Okay? It's not like you are getting the same L and you are using the same equation for both of them. Okay? So if you are using tangent length or if you are using L, both of them will have different answers. Very slight difference, but there will be a difference. Okay? So for the sake of construction, we rely on the first approach, which is adding the length. Because my objective is what? The curve. Tangent is not my problem. So if you add tangent and you don't get to the end of the curve, this is a problem. But if you go from PC and you add the length, you get to the end of the curve. Okay? So whatever difference we have, we don't want to put it in the curve. Okay? In the end, you want to fit the curve between PC and PT. Okay? You want to fit the curve between PC and PT. Even if it is not accurate from the PI. We don't know. PI is not my problem, right? My problem is start of the curve and end. Okay? So we will do how much?
33 plus 60.9.
60.9. Okay, any problem? Yeah?
The difference will be 0.16 between two equations. So perfectly we will use this one or that one. We can use both of them or only this one.
Yes, sir. Okay. On horizontal curves, we need superelevation. Why do we need superelevation? To push the car towards the road. Okay? To have the car make the turn around the curve. Okay? So we need to push the car towards the inside of the curve. Okay? So we tilt the cross section of the road so the car can go towards the curve. Okay? Now this tilting is what? The outside edge or the inside edge? Outside edge is tilted. Okay? So the car can go inside. Okay? So this is the equation of the radius. Okay? Where S is what? Superelevation, right? Speed. Okay. And which one is superelevation? E. Okay? It is normally given in percentage, but this percentage is in the section of the road. Okay, so if it is 4%, then 4 and 100 in the section, not in the length. Okay? And what else? Yeah. Okay, what is F? Your grades, right? Huh? Not the other one? The grade?
No.
No? Okay. Superelevation should range from 4% to 12%. Okay, and I mentioned this in the last lecture as well. But this is the normal range. It can be less than 4% as well. It can be less than 4% as well. Okay? Can it be 0?
It's not in the, it's not curve.
There is no curve? Okay. Anything else?
Straight line.
No.
No?
Or drainage.
For drainage. Okay, sometimes the curve is very slow or very big, or both. I have a very big curve with a very slow speed. Then superelevation is not problem. Superelevation is not the issue. Okay, but road cross section cannot be level. That's why it cannot be seen. Even if you don't need it for the safety, you need it for the drainage. Okay, not only for the curve, but in all locations. You cannot have a straight cross section because you'll have drainage problems. What other things we need to consider? Climate. Okay, in the designing super elevation, we need to consider the climate, especially the wet climate. Okay, if the road is wet most of the times of the year, okay, then we have a problem of slipping. Okay, so what should we do with super elevation? Increase or decrease? Decrease. Okay, more super elevation will have more chances of slipping. Okay, the other thing is, what's the other thing? Climate and then okay, terrain. Okay, I mentioned last time as well, we follow the terrain. We follow the terrain. Okay, meaning if the terrain is naturally steep, super elevation will be high. If the terrain is naturally level, super elevation will be lower. Okay, so conforming with the terrain. Development density. Development around the road. Okay, if the development is higher, more population, right? So traffic will be high or low? High. What about the speed?
Low.
Low. Okay. For lower speed, I need more super elevation or less super elevation? Yes. Okay. Okay. Then we have slow moving vehicles. Which are the slow moving vehicles? Trucks. Trucks. Someone truck? You are ready. Okay. So for trucks, should I increase super elevation or decrease? Decrease. Okay. Again, because of the balance problem. Okay. Slipping of balance. Okay. And the points which are given below, same points, same things are repeated, but the addition of driver comfort. Again, something which I mentioned last time as well. Sometimes the curve is fit for driving. The curve or the design is fit for driving, but the appearance is not good. Okay, it could be because of the conditions of the road. It could be because of what the driver is coming from. He's coming from a straight road or something. Okay, so because of the appearance, the driver does not feel comfortable, and he feels that it's dangerous. Okay, then the normal reactions are you slow down, you change your lane, you suddenly brake, and so on. Okay, and obviously then it can have impact on the road. You may not have a crash because of the design, but you may have a crash because the driver thinks the design is not correct. Okay, you may suddenly brake and get hit from the back. Okay, so driver appearance is also very important. We should avoid curves and super elevations and these things which are not apparently good for the driver. Okay. The same table which I showed you in the last topic as well. Okay, for the friction. Okay, we have a road with a design speed of 60. Maximum super elevation is given. And what is the maximum radius or the maximum degree of the curvature of the road? Okay, sorry, minimum radius and maximum degree of the curvature. Okay, so the radius has this equation. Okay, tell me. How much radius? Point something. 0.3. Okay, they also ask for degree of the curve. Okay. How much?
4.29.
2.2, 2.3, huh?
4.9.
4. Okay, now superelevation is, the given superelevation is maximum. So the radius is maximum or minimum? Radius is minimum. They are inverse, right? They are inversely proportional. See, R equals to something upon E, right? They are inversely proportional. So E is maximum, then R is minimum. Clear? Okay. And what about D? If R is minimum, D is maximum. Again, inverse proportional. Okay. Now let's say in the same example we fix radius of 1500 feet. Then how much will be E? If the radius is 1500 feet, how much will be the superelevation? Okay, and you took the F from this table, right? F from here for 6. Okay, now is this E allowable or not allowable? 4%. Allowable. According to what? Maximum superelevation is 6%. This value is less than 6%. It's allowable. If it was 7%, I would say not allowed. Clear? Okay. Okay, when we have a normal cross section of the road which looks like this. This is the center, and then from the center goes downwards. Okay, again for the purpose of drainage. Normal drainage is like this. Okay. For the superelevation, I don't want this. I want the outside edge to be like this, right? Okay. So I have to change it. Okay. So we change it in 2 steps. The first step is called as tangent runoff. The second step is called as superelevation runoff. Okay. What happens in the first stage? Only the outside edge goes level. Normal to level. Tangent runoff. LT. Outside edge from normal to level. Okay. Remaining superelevation runoff. Remaining will be what? The whole road. So outside edge is already level, right? So this will go from level to superelevation, and inside edge will also go from normal to superelevation. Got it? Okay. So first step, outside edge, normal to level. Second step, the entire road to superelevation. Got it? Clear? Okay. So first stage is called as tangent runoff, and the second stage is called as superelevation runoff. And this is how it happens. You can see it here. This is normal. Outside edge goes straight. Full superelevation. And at the end, reverse. At the end, reverse will happen. From superelevation to outside edge level, then normal. Clear? Okay. I am changing the slope. Changing the slope means I have to change elevation, right? Okay. Elevations are changed according to some reference. For superelevation, your reference can be the outside edge, the center, or the inside edge. One of these 3 could be the center. The most common is center. Changing this elevation and the slope is called rotation. Rotation means changing the slope or the elevation. Clear? Okay. And so this is how it will happen. This is rotation with reference to center. Okay. So let's say this elevation is x. So from here, this is normal, right? And this is full superelevation. So from here to here, this will remain x. The center will remain x. Okay. Now you can see this one. If this one is, let's say, y. Okay, so from y it goes to like this, changed. Again changed. Now you say increased, right? More increased. So y is changing. Same thing for the inside edge, because the reference is center, that's why. So inside edge, something. Then you see less, more, less. Okay? So the other edges, the elevation will change. The reference will remain constant. Clear? Okay. Now I said the most common reference is which one? Center. Okay? If you are taking the center as the reference and your road is without median, the road is without median, then center means between two lanes, right? Center means between two lanes, there is no median. The middle line of the lanes, right? Center means the middle line of the lanes. Okay? In that case, it will happen like this. Okay? Because all lanes are together, they are moving together, or they are considered as one cross section. All lanes are considered as one cross section. Okay? But if you have a median, okay, then on the median it will look like this. With the median it will look like this. One side, median, other side. Got it? Okay. So your center is the median itself now. Okay. Then in that case we don't do rotation around center, because center is the median. Median, nobody is driving at the median, or hopefully. Okay. So we do rotation at the edge of the median. Okay. Now if you look at one side, for this side median is inside. For this side median is outside. Okay. So on one direction it will be rotation around inside edge. On the other direction rotation will be around the outside edge. Got my point? Clear? Okay? Sure. Okay. Equation to calculate superelevation runoff. Superelevation runoff is this part. Okay? From the second to the last. This is superelevation runoff. Okay? So how do we calculate it? This is the equation. I need width of one lane. Width of one lane. Number of lanes rotated on one side, like from the reference. Number of lanes rotated from the reference. Say the road is two lanes and you are doing rotation on the center. So your reference is the center, right? So from the center I am rotating only one lane. So N1 will be 1. Got it? Clear? Okay. ED superelevation which you want. Design value of superelevation. Delta comes from here. Okay? Depends upon speed. Delta means rate of change in slope. You are changing the slope, right? It was normal slope, you are changing the superelevation, right? So rate of change in slope meaning change in slope per distance, per unit distance. Okay, so this is data, and then BW also has a table. That table is given in the high report. Okay, but we haven't seen it obviously. Have you seen it?
See it, that line, of course. No, it's a-
Sure.
Yeah, you know.
Huh? Who said no?
Not the highway. We didn't take this in the highway course. Superelevation one. Only the definition.
Sorry? Only what?
Definition of superelevation.
One definition?
Yes. We didn't calculate it.
I'll ask Dr. Raju. And he is saying yes, we are saying yes. Okay, what is it? Okay. Anyways, BW has fixed values which are taken from here. Okay. 1 lane, 2 lanes, 3 lanes. More than 3 lanes, then you have to refer back to the table. Okay. So we have a 4-lane highway, superelevation 4%. Okay. and we are rotating 2 lanes, okay, around the center. 4 lanes total. So from the reference, which is my center line, I'm rotating 2 lanes, okay, and the design speed is 60 miles per hour. Okay, what is the length of super elevation runoff? LR. What is the length of LR? Now my super elevation is 4%. Lane width is 12 feet. I'm rotating 2 lanes from the center. Okay, total was 4. I'm rotating 2 from the center. That's why. Okay, anything else you need? Okay, tell me, how much is LR? BW for 2 lanes, how much? 0.7. Yeah. 160. Yes. Really? We are saying to take it. Will you take it? Okay. LT, the first part of super elevation. Okay, LT is the first part of super elevation. LR was the second part. Okay, LT is this one, from first to second. Okay, normal outside edge to double outside edge. This is LT. And LR was this one. The one which we calculated is the other one. Okay, now we are calculating this one. Okay, so to calculate this one, as you can see in the equation, normal slope, super elevation, LR, the one which we just calculated. Okay, the second part. Okay, so to calculate the first part, I need the second part. Okay, so let's say in this example, the previous example, now my super elevation is 4%. So ET is 4%. Normal slope is, let's say, 1%. Okay, and LR we calculated to be 160 feet, right? Okay, so if we put these values, we get 40 feet as the first part. Okay, so first part 40, second part 160, total 1. Okay, so to go from normal to full super elevation, I need total transition length of 200. Now I'm doing this for the curve, right? I'm doing this for the curve. Before the curve, I have the tangent. Before the curve, there is a tangent. So we divide this transition into tangent and curve. This transition is divided into tangent and curve. Normally, 67% on the tangent, 33% on the curve. So out of 200, 67% will be on the tangent. The last 33% will be on the curve. What? Because the tangent is straight, right? So to make the change here, it's easier. So we make the 67% change on the tangent, the straight part. Then the remaining 33% on the curve. Okay. In some cases, we do 80-20 as well. So 80 on the where? Tangent on the curve? Tangent. 80 on the tangent, 20 on the curve. Clear? Okay. Any questions?